All right, so now I'm going to do example 2, which is actually now finding the probability of an independent event. So if you take a look at our first spot here, okay, it says events are independent, which we know if the occurrence of one event does not affect the other one, okay? All right, now in order to find the probability, that's going to be right here, okay? So if A and B, which are your two different events, are independent, one does not affect the other one, then that's how we're going to write the probability. So it's probability of A and the event of probability of B. So what we're really going to do is actually just multiply the probabilities together. All right, so let's take a look at an example. All right, so looking at this first one here, it says an experiment consists of rolling a number cube twice. It says here, what is the probability of rolling a 3 the first time? So that's event 1, rolling a 3 the first time, and then rolling a 2 the second time, okay? All right, so we know that these events are independent because when I roll my first one, it's not going to have any effect when I go and roll the second one. All right, so let's find the probability, and this is how we're going to write it, okay? Probability, rolling a 3 first, then rolling a 2. All right, so the probability of me rolling a 3 on the number cube, well, remember the number cube has 1, 2, 3, 4, 5, and 6. Those are all the different outcomes of rolling when we roll a number cube. So rolling a 3 is 1 out of those 6 chances. So notice that's the probability, 1 out of 6 chances. That's for rolling a 3. Then if we rolled that same number cube again, what's the probability that on that second time we roll a 2? We're rolling a 2 would be the same probability, a 1 out of 6. That's another 1 out of 6. So for the probability of rolling a 3 first, 1 out of 6, then rolling a 2, that's 1 out of 6. Now we multiply them together. So 1 times 1 is 1. Over on the bottom, 6 times 6 is 36. So that probability would be 1 out of 36. Or you can write it in decimal form as well. So 1 divided by 36. In the calculator, you get 0.027. Remember, you multiply that by 100. That's also a 2.7% chance of rolling a 3 and then rolling a 2. All right, let's take a look at the second example. So at the second example, do this one in purple here, okay? It says an experiment consists of randomly selecting a marble from a bag and replacing it. So that's a key word there. That's going to now make our event independent. If I didn't replace it, then that would be dependent. That would be like the first example that we did, your sister going after your turn, like selecting a game piece. All right, so we have a bag and we're placing the marble. We take one out and then we place it back in. So it says here the bag consists of 2 red, 1 white, and 7 yellow marbles. So all together in our bag, 2 plus 1 is 3 plus 7. There's 10 marbles in our bag. So that's going to be down on the bottom is 10. All right, so here's the question. Here's the probability that we have to figure out. What is the probability of selecting a white and then a yellow? So we know it's independent. I'm going to multiply the two probabilities together, okay? All right, so selecting a white first. Well, in our bag, we have 1 white marble out of the total 10. So notice down here, the probability of selecting a white would be 1 out of 10. Now I'm going to place that marble back. So I still have 10 in my bag. So now for the second time, I'm going to reach back in. What's the probability that we select a yellow? Well, there are 7 yellows. So here, that would be 7 out of 10. So selecting a white would be 1 out of 10, putting that back in. Now I go in for a second time selecting a yellow, that would be 7 out of 10. So multiply them together. 1 times 7 is 7 over 10 times 10 is 100. So you can leave it like that, or you can type it into your calculator. 7 divided by 100 is 0.07 as a decimal or a percent. That would be a 7% chance that you would pull a white and then a yellow. You can even add another question to that. So say, for instance, that was our question, pulling a white, then pulling a yellow, and then even I could add a third one. What's the probability of pulling a red? So at a red, that would be adding to this or multiplying to this, I should say, 2 out of the 10. And you can continue to do that. All right, let's take a look. I'm going to erase some of this so that we can take a look at this first question here, okay? All right, so question number 1 says 6 cards are numbered 1 to 6 and placed in a box. 1 card is selected at random and replaced. All right, so that's a key word there. Replaced means, I'll pick my favorite color, which is teal. Replace means that these events are going to be, it didn't work, independent. Let me see if I can do that again. Selecting blue. Okay. All right. So it says here, another card is selected at random. What's the probability of selecting a 1 and then a 6? All right. So in our box, we have 1 through 6. Okay. So just like the number cube in a sense. All right. So what's the probability that we select 1? Well, that's a 1 out of a 6 chance. What's the probability that we select a 6? Well, that's a 1 out of 6 chance because there's only 1 6 in those numbers. So now when we put the probabilities together, what's the probability of selecting a 1 and then a 6? Well, that would be a 1 out of 6 times 1 out of 6, or 1 out of 36 chance that we're selecting a 1 and then a 6. All right, let's take a look at number 2. Number 2 says here, a coin is tossed 3 times. So it's the same coin, but we're doing it 3 separate times. What's the probability that the coin lands on head all 3 times? All right, so for the first time, landing on heads, that's a 1 out of 2 chance. Then we flip the coin again. Well, all of our probabilities start all over again. It's an independent event. So selecting a head or flipping a head would be another 1 out of 2 chance, 1 head out of 2 possible outcomes. And then for a third time, now we just multiply it again, 1 out of 2. So 1 times 1 times 1 is 1, over 2 times 2 times 2 is 8. So selecting or flipping a head 3 times would be a 1 out of 8 chance. All right, take a look at 3. 3 says here, a bag contains 5 red, 8 white, and 7 green marbles all together. So 7 and 8 give 15 plus the 5 red. There's 20 marbles in our bag. Okay, so the question says, what's the probability of randomly selecting a white and replacing it? So replacing it means it's going to be independent. So we need to select a white. So the probability of selecting a white, replacing it, and then selecting another white marble. Okay, so the probability that we're getting those 2 white marbles here after we replace the first one. All right, so we have 8 white marbles. So for the first marble that we pull, that's an 8 out of 20. And then we're going to put that marble back in the bag. And now we're going to pick again. So now when we pick again, there's still 8 out of 20 marbles that we can choose from. Okay. Now, with these fractions, you can reduce them. So for instance, 8 over 20, divide both top and bottom by 4, and you get 2/5 times 2/5, or we can write that as 4 over 25. Remember, you're multiplying those numbers together. So selecting a white, replacing it, and then selecting a white marble again, that would be a 4 out of 25 chance. All right, and then the last one, number 4, says here, 10 cards are numbered 1 to 10, placed in a box. 1 card selected at random and then replaced. All right, so keyword again, independent. Another card is selected at random. What's the probability of selecting now it says here, a multiple of 3. Now, multiples of 3 are when you multiply them by 3. So like multiples of 3 are 3, 6, 9, 12, and so forth, okay? But we only have up to 10. So in that number box here, number multiples that I have of 10, now there are 10 cards, so it's out of 10. So for our first one, multiples of 3 would be the numbers 3, 6, and 9. Those are all multiples of 3. 12 isn't in there because remember, our box only goes up to number 10. So there's 3 out of 10 that are multiples of 3. All right, now I'm going to put that card back. And then they want, for the second one, multiples of 2. Well, multiples of 2 are 2, 4, 6, 8, and 10. 10 is in there. So here I have 1, 2, 3, 4, 5 out of your 10. So now when I multiply that together, I can reduce 2. So like even the second one, divide top and bottom by 5, that's 1/2. So it's really 3/10 times 1/2. That would be a 3 out of 20 chance of selecting a multiple of 3 and then a multiple of 2. All right, so now go back to homework on page 754. Let's do numbers 7 through 11. These are all independent events. You're going to multiply the probabilities like this.